Hello. This is the lesson for Thursday, April 15th. What you see up above is a continuation from our lesson on Tuesday. So if you click on the notes and practice from either Tuesday or today on today's page, you should already have this part or something very close to it. This was when we were practicing calculating molar mass and then realizing that if 1 mole is equal to the molar mass, then we can start using it in different relationships, either a half a mole, 2 moles, etc., etc., etc. If you don't have this down yet, pause the video, get all this down, make sure it makes sense, and then start on in. Alright, so now what we're going to do is we're going to look at these relationships kind of like we did with the 22.4 liters in a mole of a gas at STP. Instead of giving nice even numbers like 2 moles and a half a mole and things like that, we are going to actually kind of look at some of these with a little bit odder numbers. But you can still use the exact same way that we have been doing in order to solve. Okay, so again, I have this split up into 2 sides. You have the given in mass, which is on the left-hand side. And then what we're looking for is moles on the right here. And then on the right-hand side, it's the opposite. The given number is in moles, and what you're looking for is grams or mass. Okay. So the first thing you have to realize in any of these, again, your connector between the two, mass and moles, is the conversion factor that 1 mole is equal to the molar mass, and that's in grams. But that's of the particular substance. So your molar mass, the number that's going to go right here, or the number that you're going to put in your fraction, is dependent on the molar mass of the substance. So whenever you approach the problem, the very, very first thing you should do is find the molar mass of the substance. Whenever you see that it's asking for mass or grams and it's given moles, the very first thing you're going to have to do is find the molar mass. So let's do that. Okay, so I'm going to find the molar mass of water, because this is the one that's here, and then we're just going to go ahead while we have all our periodic tables out. We're just going to go ahead and find the molar masses of sodium chloride, because that's for the other one. Okay, so speaking of periodic table, why do I not have mine out? Silly me. All right, so let's look up. We've got hydrogen at 1.01. We have oxygen at 16.00. We have sodium at 22.99, and then we have chlorine at 35.45. So those are all the numbers that we're going to need. So I'm just going to kind of put these out to the side. Hydrogen is 1.01, but of course we have 2 of them, so we're going to have to multiply that by 2. And oxygen is 16.00. And then over here, I'm going to put the sodium is 22.99, and chlorine is 35.45. 4545. Okay, so again, you're going to multiply and then add. This is just 1, so you just have to add. Go ahead and pause the video, figure those out, and then come back to me. All right, you should have found that water is 18.02, and that I didn't do this one. I'm just making sure it's early. 34.45. It should be 54, but yeah, 57.44. Okay, so those are your molar masses, and that is in grams for every in 1 mole. And so I'm going to write it like that: grams in 1 mole. So that's essentially our conversion factor. Okay, so now let's get into what we're actually doing. So in the one on the left, it's asking for how many moles. So that's what we're looking for, is how many moles are in a 12.3 gram sample. So our given 12.3 grams of water. Now we have to fill these spaces. Okay, we have to fill these spaces. So to remember what goes where is what is up must come down. So if grams are here, then I know that grams are going to go here. So that means 1 mole is going to go on the top. Okay, whatever the other space is, if this is going to be grams, then the other space is always going to be 1 mole, no matter what. It works that same way on the 22.4 liters in every mole as well. Okay, so now what goes here? The molar mass does. Okay, so I'm going to label these real quickly for you. So this, essentially, this whole thing is this put in a fraction form. Or you can think of it as like this being the molar mass, and that is equal to 1 mole. See how it's like that and it's just put on its side? Okay. All right, so now that we have it set up, now you can probably easily see what we have to do to solve the problem. So we have 12.3 on top times 1 is 12.3. We have 18.01 is on the bottom. So if it's on the bottom, we know we're going to have to divide it. So we're going to have to divide 12.3 by 18.05. Where do our units go? Well, grams cancel, grams cancel. So our unit is going to be moles of water. So let's run this through the calculator and see what it is. Okay, so we've got 12.3 is on top. 18.02 is on bottom, so I'm going to divide. And I get 0.682749. Okay, so where am I going to round this to? Well, I've got 1, 2, 3 digits. The 0 doesn't count, so I'm going to go 1, 2, 3 digits. So I'm going to go with, I'll write it over here, 0.683. Moles of water is the same thing as 12.3 grams of water. So if I had a bag of water and it was labeled 0.683 grams, or sorry, moles, what if you had a scale, you plop it on there, it would equal 12.3, just like we did when 1 mole of water was equal to 18.02. Okay, next, let's try the other one. In this case, how much would 0.67 moles, so that's our given, oh sorry, that should be in yellow, my bad. This is our given right there, of sodium chloride weigh. So how much, meaning, you know, whenever you see how much, that's kind of a vague way to say mass, but usually it's almost always mass. So what is the mass? Okay. So we're going to start into this since we already have the molar mass. We don't have to go do that. Again, a lot of times on a worksheet, that might be the first thing you do, or if you have a set of problems, the very first thing you do is just go find the molar mass of whatever it is. And that way you're just set and ready to go. So our given is 0.67 moles of sodium chloride. Okay. So what is going to go in my next fraction? What is up must come down. So I'm going to have mole here, and I know that whenever it's a mole, it's 1. We've got 1 mole. So what goes on top? Well, that means the other part of this, which is the molar mass, which we've already calculated right over here. 57.44 grams in 1 mole. So now when we look at this, we can see, okay, well, grams are on top. Obviously, moles are going to cancel with moles because they're in, one's on top, one's on the bottom. So what are we going to do? This is just a multiplication problem right across the top. It's just 1 on the bottom. And again, remember, if you want to put 1 there, it's the same thing, right? If I put a 1 here, it's the same thing. It's just a different version of filling it. All right, so now I'm going to multiply across the top 0.67 times 57.44 is 38.484. I'm realizing I made a mistake on here, and I knew it when I did it. Okay, chlorine, and you look it up, it's actually 35.45. So this is actually 58.44. I'm sorry. I knew something looked odd. Okay. So let me try that again then, now with a new molar mass. 0.67 times 58.44. And we get 39.1545. Okay, all those numbers. How many are we going to round to? We've got one number here, two numbers. The 0 doesn't count. So one number, two numbers, that's just rounds to a nice, even 39. And so we end up in, what's our unit? Grams of NaCl. So if you had a bag that was labeled 0.67 moles of sodium chloride, when you put it on that scale, it would weigh 39 grams. It's the same. These two numbers are the same thing, just in different units. And throughout our labs and throughout our lessons, sometimes we need things in grams and sometimes we need them in moles. That's just kind of the way. Sometimes the numbers that you get are not the numbers that you need, and you need to be able to convert them. Okay, so let's take let's back up and look at both of these problems. And what do we see? Oh, it follows the exact same pattern as we saw before. If your given is in grams and you're trying to get to moles, what mathematical process do you do to solve it? You divide by the molar mass. If you're given moles and you're trying to get to mass, what mathematical thing do you do in the process? You multiply by the molar mass. So this is a way for you to set it up in case if you're not getting the pattern of anytime you're getting to moles that you divide, and anytime you're getting to going away from moles you multiply. So use this as you need, but as you start getting better at these, if you just recognize, oh, I have to divide, oh, I have to multiply, that's fine too. But I would appreciate a little bit of work on your problem so I can see what you did, because a lot of times students will make a little error, like a molar mass error, or they'll flip the thing around, and I can give you partial credit if I can see what you did. Okay, so for the rest of the period, I would like for you to work on the practice. So if you scroll up on your digital copy, or if you flip over your paper, if you have a paper copy, then these are the 5 problems I would like for you to do. Again, first thing you might want to do is go do your molar masses of your substances so that you have those done and out of the way. Okay, so do the molar masses of your substances, and then figure out what's given to you, figure out what are you trying to find, and then once you have that, you can figure out which one of these processes are you going to divide or are you going to multiply. All right, good luck, and have this done by the beginning of class tomorrow, please.